the mid-19th century, Francis Galton developed the concept of regression and correlation as a consequence of his interest in heredity and evolution. Originally, the idea of correlation and regression was associated with measuring the same trait in two related samples. For example, measuring height in parents and then measuring the same trait, height, in children. So we've got the same variable, height, measured in two related samples. The concept of correlation and regression then was expanded to not only to the cases in which the same measurement happened in two related samples, but also to different measurements in the same sample. Like, for example, instead of investigating the relationship between the height of parents and the height of children, we can investigate the relationship between the height of people and their weight. Here is a way of representing two related samples measured with the same variable, or two different variables measured in the same sample. So, for example, variable x could be a variable that have possible values from 0 to 100, and variable y is the same variable with values, of course, possible values between 0 and 100, and this is measured in two related samples. For example, x could be the height of children and y the height of parents. Or two related samples could be the same person, the same sample of people. So, for example, x could be the measurement of fatigue at a certain point of time, and then y could be the measurement of fatigue at another point of time in the same group of people. And as I mentioned, the other option is that x and y are completely different variables, but they are measured in the same group of people. So the key of the concept of correlation and regression is that we've got two measurements, and those measurements are done in related samples. The way of representing data here are those two measurements, or two variables, are presented independently. But what Galton discovered is that a way of representing the two variables together became very useful. And that's the scatter plot. In the scatter plot, we've got the two variables, or the same variable, measured in related samples, x and y. We've got x in the x-axis and y in the y-axis. And each dot represents one observation, represents one person. So, for example, the point to the left of the slide, which is between 10 and 20 in variable x, that is a person who measured between 10 and 20 in variable x and between 50 and 60 in variable y. And every point in the diagram, it's one person and showing the scores in x and the scores in y. In this diagram, Galton shows the relationship between the two variables could be represented by lines. These then are called what we call regression lines. And those lines represent some aspect of the relationship between these two variables.